Behind me today we've got Chris's Fiesta ST180 Mark 7, or known as Mark 7.5 depending on who you're speaking to. This car's with us today for a full Peron Stage 2 Pro kit. We've recommended certain products based around Chris's specification. He's coming for the 2 Pro to start with, as it's quite cost effective. So I'm going to run through a list of some of the bits and pieces that would fit into this vehicle today. Now, Chris did make it quite clear to us that at some point he was hoping to come back, do some suspension setup and some brakes. Then he may or may not go to a Stage 3 kit. So we made the recommendations on hardware based on the fact that we'd get the maximum out of the Stage 2 Pro Peron, but it would handle Stage 3 if he decided to go to that in the future. So as part of this kit we are going to install a Pro Alloy curved intercooler, which the reason that we've recommended the curved intercooler for Chris's car today is solely down to the fact that it's a tube and fin construction, so it's very quick to recover and it doesn't have an enormous pressure drop across it. So for a Stage 2 Pro where you've not got a larger turbocharger pushing a volume of air through it, it actually performs a little bit better on Stage 2 Pro, but it will handle the Stage 3 kit. On top of that we've got the ITG induction kit and ITG crossover pipe with an inlet pipe to suit, so that would essentially again take him all the way to a Stage 3 specific kit. We have decided to go with our Voodoo downpipe purely because of the quality of the product, and we've tested it on our race cars and we've proven it to sort of 300 wheel horsepower plus. Callum has started this job and it's probably really important for me to get this across whilst we've got the opportunity. Typically now with these vehicles we are finding that the bolts are snapping and things like that, and this is why, whilst it's probably possible for somebody who's handy with the spanners to do this on the drive at home with a little bit of difficulty with the car up on axle stands or whatever, if you snap a bolt, which we have done here and this happens more often than not now, and the turbo has to come off, it becomes a real big job, and ultimately 9 times out of 10 customers that have done this end up in a position where they have to wind the bolt back in, abandon the job completely and then ring somewhere like here to try and get it over to us so we can then take the turbo off. Today I am going to be showing you guys a Voodoo big boost pipe kit that we've developed for the Fiesta ST180, also known as a Mark 7 or Mark 7.5 for the guys who know it as a facelift. The reason behind us developing our own kit was, as you can see here, I've got the original, or some of the original pipe work, which is considerably smaller, but also this consists of a resonator which dampens noise down but also saps power. So we decided that there are other parts of the kit which is all messy and dirty, so I can't show you that today, but it goes up and down in varying sizes, but this is its smallest diameter here, which we've changed. So I've measured this already, and this is about 1.5 inches there or thereabouts around here where it goes to its smallest point. So we have managed to increase the pipe diameter, which of course is going to aid in airflow. It's going to create less heat because of course a smaller pipe with more boost trying to be pushed through it is going to create heat, we all know that. So our pipe kit is just short of 2.5 inches, it's about 2.4, 2.35, and it's a solid piece all the way through, so it's mandrel bent, but it's in this box here, so I might as well open this up now and let you have a look at it, and I'll go through some of the features whilst we do that. I should probably start with the pipe work because it's a bit more interesting and a little bit more important. So the pipe work, as I discussed before, is just short of 2.5 inches, so you can see the diameter change here. So not only does that aid in airflow, which is going to create more power, but it keeps everything cooler because you're not superheating the boost pressure as it comes through. Also, obviously on the hot side, you've got your intercooler. If you're feeding colder air into the intercooler, it's not having to work as hard to cool it even more, whereas you're feeding hot air in because you've pressurised it too much through this. You are going to be feeding a higher temperature air, so the intercooler has to work even harder to get it down to ambient. Again, we'll try and get in close on the welding on some of the shots, because again the welding is particularly good on these, and we obviously pride ourselves on quality and we're not the cheapest. So that's the pipe work. The other part of pipe work here, which again we should probably try and show you in a bit more detail, the welding is obviously very good. The boss is a machine specifically to take the bottom boost sensor, and the pipework is mandrel bent rather than having loads and loads of welds, which obviously create somewhere for it to crack or you know, potentially leak some boost pressure. We are on day 2 and we're nearing the end of the build on this Stage 2 Pro car. Callum has fitted all the hardware that I've previously gone through, and we are now more or less ready to take the car off the ramp and into our dyno cell. So I'm going to do a little bit of explanation as to what happens during the process of tuning and how our dyno works by comparison to something like a rolling road. Be a good opportunity for us to talk through the difference between our DynoPack hub dyno and a typical rolling road and how ours works. So the hub dyno removes the wheels and bolts directly to the hub. The reason that sort of the high-end tuning companies like these purely because it takes out any rundown exposure, i.e. when you see a car on a rolling road and it runs up, it's also measured on the way down when it's on coast down. This can be affected, the reason this can affect figures at the engine is essentially due to things like tyre pressures, how sticky the tyres are, how hard it's strapped down. You know, all of these elements are things that you're trying to move away from during the process of tuning, so that you can get an accurate figure back to back every time. So that's why we decided to invest in the hub dyno. So the process behind loading this onto the packs, as we call them, is lift the car up, remove the wheels. You'll see that there is a adapter which bolts directly to the hub, and then the hub pack is splined and slides over the top of that, which requires no straps. The car doesn't need strapping down. Once it's dropped off the jacks, it's sat splined in and locked in so it can't go anywhere. So aside from the obvious of not having the wheels and what we've just gone through, it means for something that's got an awful lot of power, and these Fiestas are well known for coming on boost very aggressively. On a typical rolling road, it can result in wheel spin, and we see that a lot, and that is obviously going to affect the graph. You get dips and all that sort of stuff. It's also meaning that it's taking out any inertia, so it can be used for tuning more accurately. Inertia obviously smooths the graph out, when actually it's not probably as smooth as it might look without that roller in place. So it's an oil-filled pack which gives us the load basis rather than running on an inertia-based or a braked dyno roller. So this is one of the main dynos that the bigger tuning companies use, big race teams, all that sort of stuff. It is a little bit more labour intensive, having to lift the car up and take the wheels off rather than strap it down, but overall it's going to give you a more accurate result. You're going to be able to repeat the result over and over again, so it's going to be consistent. A fan of our stature, which hopefully we've got some shots of, coming through the wall with an outside fan rather than just your typical plug-in ones that you see at some of the smaller dynos. This is going to mean that you've got a consistent level of cold air, if the ambient allows, blowing into the intercooler and keeping everything at a good ambient temperature so that you can again get consistency with your results. So coupled with the fan that we've got outside, it's important to think about the extraction. Obviously you can have a lot of exhaust gas, particularly inside the dyno cell that we've built to help with sound deadening and things like that, but I'll explain a little bit more about that later. The extraction, if you're not extracting the exhaust gas, not only is it not good, secondly, you're having to blow it out of a door onto a street, which obviously you're going to have noise restrictions on some industrial estates, particularly when they're getting more and more built up. Industrial estates are becoming really, really busy, and a lot of businesses that have offices, they don't want to hear cars being run. So the extraction is really important. Ours is a particularly good one which goes up out of the roof and takes it away from anywhere that it's going to be blown onto, you know, public places, and also it's good for extracting the noise upwards as well as the exhaust gas. Aside from that, if you're not extracting the exhaust gas quick enough, that's going to recirculate into the fan area, and you're ultimately going to end up blowing hot exhaust gases back at the intercooler. So coupling it all together, the final piece of the puzzle really is the cell, which hopefully we can get some shots, but sound deadening is really important for a couple of reasons. One, obviously, guys working up in our offices, we don't want to listen to the dyno all day, as fun as it is, but also other general public, and we've got some housing estates out the back there. I can confirm when this dyno cell's shut, we can run it in the middle of the night, and the guys over the road in the public housing, they don't hear us running the dyno cell, so it's important for that. Another good reason for having the dyno cell where we can shut the car in is obviously this is a process where the car can be going upwards of 150 miles an hour in some cases if you've got longer gear ratios. Having customers in and around a workshop facility with a dyno that's exposed, if anything does go wrong, which we've all seen the dyno videos, you know, where they go wrong on YouTube and things, you know, not everything can always go to plan. If the worst should happen and it's inside a controlled cell like this, nobody's going to get hurt. You know, the worst that can happen is if a car comes off the dyno or something like that. Ultimately, the dyno operator is inside the vehicle, so it'd be no different from crashing on the road, except in a building that's blocked in. Ultimately, what we want is safety for our customers, and that's one of the main reasons for having a cell where the customer can sit in the waiting area, still view through the windows and enjoy what we all do this for, but ultimately they're safe. The final part of the tuning process for us is taking the customer's vehicle out on an extended test drive. We tend to try and, you know, on something that's a considerable build like this, you know, a minimum of 15-20 minutes, take it out. If there's anything that we haven't found on the dyno, within 15 or 20 minutes you're going to find it out on the road. Now, it's important to note that during the test drive, obviously it's not our vehicle, so it's treated with respect, but we do need to put some boost through it, and we do need to sort of reach the higher end of the rev range. So we tend to start by warming the car through, taking it down some of these dual carriageways that we have local to our work, and then after that we'll open the car up within reason, where we're not putting anybody in danger, just to make sure that everything's absolutely fine before handing it back over to the customer. The end of this process. Hopefully you've enjoyed seeing what's gone on. Just thought we'd run through some of the figures that this car's made. Now, naturally it's a little bit warm, it's some sort of height of summer now, so the humidity's up and ambient temperatures, but we've still managed to achieve 212 wheel horsepower, which is circa anywhere from 240 to 250 at the engine, depending on which dyno you go on and what the rundown works like and so on and so forth. We've made a massive 290 feet-pounds of torque, so this car is producing really, really good torque figures and good power, particularly for the temperature at the moment. As I said before, the Pro Alloy cooler is particularly good on a Stage 2 Pro car due to its tube and fin construction, so if you're considering Stage 2 Pro for a long period of time and then a jump to the VT330R or an alternative turbo for Stage 3, the Pro Alloy the curved cooler is a very, very good option. I'm confident this customer is going to be absolutely in love with this car, and I have no doubt that we'll see him again in the future.